All right, so chapter three. Chapter three, chapter three is the first time we kind of do something new. We still talk about the same stuff we did in chapter one and chapter two, but we're kind of moving into something a little bit new. Chapter one and two are very much related, but chapter three is a little different. The big thing about chapter three, the big difference about chapter three is this word called these two words called bivariate data. Bivariate data. So BI, if I put BI in front of a word, what does that do to what does that mean? Two means two, right? So today, or this chapter there's two sets of data. Look at the first table. I have two sets of data. What's the first one? Body weight, how much the person weighed in pounds. Now I have another set of data. Backpack weight, different, right? In all of our notes before, we only had one set of data. One, whatever it was, heights, temperatures, grades on the test, whatever it was, we only had one. Now we're comparing two variables, an x and a y. Okay? So the first one is, what are those variables? One is called the explanatory and one is called the response. If you've taken psychology, you know those words. You've heard those words before. Response and explanatory. Okay? Maybe another science class too. Other science classes talk about explanatory and response. So what are they? Response. Response is how you measure an outcome. How you measure an outcome. Okay? The outcome is what happens after, right? That's the outcome. What is explanatory? Explanatory may help explain or influence changes in a response variable. So for example, an explanatory is something they introduce to a population or to a sample, something that's introduced. Response is how they reacted, what happens after. Because I did this, how did they respond? Okay, so in other words, the explanatory is the X, response is the Y. Okay, that's how those two are related. All right. So the first example, we're going to introduce a new graph, scatter plot. Okay, I think scatter plot. Yeah, scatter plot's the last type of graph that we haven't done a scatter plot yet. It's the last type of graph that we're going to have to do. We still have those others: histogram, box plot, stem and leaf plot, dot plot, all of those, box plot, all of those. We still have all of those, but now we have a scatter plot as well. Okay, so data. So we got to make a scatter plot of the relationship between, there's always a relationship between two things. This one's between body weight, how much a person weighs, and their backpack weight. Okay, so how this data was conducted was they measured a person. They put them on a scale, how much do they weigh? The first person weighed 120 pounds. Okay, 120 pounds. Then they measured their backpack, how much their backpack weighs? 26 pounds. So this is one person. So this is one person here. Okay. The second person weighed 187 pounds. Their backpack weighed a little more, 30 pounds. Okay. The third person weighed less, 109 pounds. Their backpack weighed 26. So on and so forth, right? So total, there were 8 people that were asked 2 questions. Remember when we did the heights? When you guys measured yourself, how tall you were? I only asked you 1 question. How tall you are, right? Bivariate data asks 2 questions. So this one, when they did this survey, they asked 2 questions. How much do you weigh? So go weigh yourself. How much do you weigh? And then how much does your backpack weigh? Okay, so that's why it's bivariate data. It's 2 separate things. Okay. So how do we graph it? Well, it's not hard, but since we have bivariate, we have to graph it on an x and y axis. Okay. We only need the positive. I only need the positive quadrant because all of the numbers up here are positive. There's no negatives up here. None of the weights, backpack weights, or body weights are negative. So I only need the positive quadrant. Okay. I have the x axis and the y-axis. How do I determine which one's the x and which one's the y? Now, I know you guys are programmed to say, oh, well, this one is the top one, so that's going to be the x and that's going to be the y. Not necessarily the case in this chapter. Sometimes they do that. Sometimes they flip around. Sometimes they put the y on top and the x on bottom. How do you determine that? Well, you try to determine what they're trying to do. What are they trying to find? They're trying to find the relationship between body weight and backpack weight. So what question are they trying to answer here with this data? They didn't give me the question, but what question are they trying to answer with this data? Can anyone does anyone see what question they may be asking? Why they got this data? Why did they get this data? Why did they choose body weight and backpack weight? What was the question they were trying to answer? Mm-hmm. The opposite. They were trying to say how much a person weighs. If I weigh more, if I'm a bigger person, is my backpack going to weigh more? So what they were trying to say is based on your weight, your body weight, does that affect how much stuff is in your backpack? That's what they were trying to. So if that's the case, body weight is going to be the X, backpack weight is going to be the Y. So it did work out. Top is X, bottom is Y, but it's not always that way. It's not always that way. The question they were trying to answer was, does body weight affect backpack weight? So just because I weigh more, does that mean my backpack's gonna weigh more? Okay. Or does it not have nothing to do with each other? Right? You walk around campus, you see people with huge backpacks. You see people with, I don't even know why they're wearing a backpack. There's nothing in it. It looks flat, right? Does their body weight, how much they weigh, determine what their backpack's gonna weigh? That's what we're trying to figure out. Or is it just random? Okay. So since we know that, body weight is going to be my X. So I look at my X numbers. My X numbers start at 103, and then the heaviest person's 187. Okay, so I'm going to label. But I'm not going to start with 0. I don't want to start with 0 because all of my numbers are in the hundreds. So I'm going to do one of these guys. That means I skip ahead a bunch of numbers. My lowest number is 103. So I'll probably start with 100. My highest number is 187. So I'll probably go by 20s. Let's see, 180, 200. There's no one over 200. There's no one below 100. Backpack weight. Backpack weights are not as high. Oh, so we want to label here. Wait, let me label. Underneath this guy, I want to put what they are, pounds. Right, pounds. All of these are pounds. Now I'm going to put the Y. Well, the Y's backpack weights start at 24 and they go up to 35. So I'm going to do the same thing I did. I'm going to skip a whole bunch of numbers because I don't want to have to go, because most of them are. I'll start with, what is that? I'll start with 20 and go by 5s. And I don't think there's anything above 35. Okay. That's the first thing we do. And then I got to label this side. This side is pounds. I should probably, since they're both pounds, what I should do is also put body weight so I know which one's which, and backpack weight. Okay. Okay, so how many people did we say were asked the questions? Or how many people do we have data from, I should say? 8. So each person's going to be a dot. Each person's going to be a dot. So the first one weighed 120. So I'm going to go to 120 and then 26. So I'm going to go up 120 up 26. 26 is a little bit above 25. That represents the first person. And I'm going to do that for the others. 187.30. So 187 is almost halfway between 180 and 200, and 30 is right there. All right, 187 is right about there, and 30 is right about there, so that's where they meet. Okay, next person, 109 and 26. $103 and 24. $131 and 29. $165 and 35. $158 and 31. Let's see, $116 and 28. And that's it. So I should have 8 dots, each one representing a person. That's what's called a scatter plot. It's a plot kind of scattered. Each dot represents a person. So if I had 20 people, I'd have 20 dots, but I only have 8, so I have 8 dots. Okay, so this is what we're going to do. What kind of statements can we make about the overall? Not one dot, not 2 dots, but overall. What kind of statements can we say overall about those dots? In context, meaning, okay, there's a cluster where? From 103 to where? So 103 to 131. Okay, there would appear to be a cluster there. They're kind of clustered together. Okay. What else could we say? What else could we say about everybody? Not just necessarily like half of them, some of them. What could we say about the whole thing? How could we put it in one sentence? How could we sum up like what's going on here? Yeah, Ella? Exactly. As I get bigger, so as I go this way, what's happening to backpack weights? What's happening to the height? So as I go to the right, as I get heavier people, what's happening to the dots? Are they climbing? Are they falling? Are they staying the same? They look like they're climbing a little bit. Not too much, but they look like they're climbing. As I go this way, it looks like the dots are kind of getting a little higher. Not so much this guy right here, but it looks like they're climbing, right? Compared to these guys over here. It would appear, right? So to say, you can say as body weight increases, backpack weight seems to be increasing as well. That one sentence tells me what's going on. That's what I need to know. It tells me about the whole picture. Now, is every single dot getting bigger? No, look at this dot right here. This dot should be somewhere probably up here, right? But it's not. But overall, the picture is showing that as my body weight gets more, Backpack weight gets a little bit heavier. Makes sense, right? If you're a heavier person, you can lift more weight, right? So that's what it's trying to say. That is what the relationship is saying. There's a relationship. As one gets bigger, the other is getting bigger as well. Okay? So relationship, that's how you describe a relationship. What happens as X gets bigger? Is Y getting bigger? Is it getting smaller? Is it staying the same? That's how you describe a relationship. The next one we're going to talk about is how you describe an association. Association's kind of similar, but a little different. Association has three parts. It has strength, it has form, and it has direction. Okay? So form is the easy one. It's always linear. In this class, we don't talk about anything but other than linear. So you don't have to worry about nonlinear. It's just form is always going to be linear in this class. We only talk about linear relationships or associations. We don't talk about nonlinear. Don't have to worry about that. You won't be tested on it. It's not on the AP test. So it's just linear. We used to do that. That's why I was on there, because we used to cover nonlinear relationships, but we don't have to anymore. Okay? Okay, so strength. What does strength mean? Strength is how confident you are in what we said earlier, right? What we said earlier. As body weight's increasing, is backpack weight's getting bigger. How confident are you in that statement? Like from 0 to 100%. 100% confident? Yes, absolutely, 100%. It's going up. All the dots are moving up. 50% means like, yeah, kinda. Strength is how confident you are in that statement. Okay, how confident are you in saying, as body weight increases, backpack weight will increase as well? Weak means I'm not very confident. I'm not very confident at all. It is, but I'm not like very confident. Thanks. Okay. Moderate is like decent confidence, somewhere in the middle. Strong means super confident. Every dot's doing the same thing. Every dot's doing what they should be. As I get bigger, as body weight gets bigger, every dot's doing what they're supposed to be doing, going up. So if you were to look at that, which one would it fit best for you? Weak, moderate, or strong? I would say pretty moderate, right? This guy right here, if this guy was a little bit higher, I would be pretty strong, right? I'd say pretty strong. But this guy is kind of not cooperating. This guy's a little low. This person weighs a lot compared to the rest. I'm not saying they weigh a lot. I'm saying compared to the rest, they're on the high side. So they also should be on the high side for the other one too. Shows for backpack weight, right?
Yes. Yeah, at the end of the period, perfect. I'll send them. Okay. After we're done, Miss Monroe needs to give you something. Room 11.
Yeah, towards the end. When we're done, we'll finish up a little early and then you can go down there. Okay, so yeah, I would say about a moderate, right? Moderate, maybe, like I said, it's just that one dot over here that's kind of not cooperating, right? What would strong look like? What would a perfect strong look like? Perfect strong would be the dots line up perfectly and they're all going up like that. That's perfect world strong, right? That's the strongest it could be. The weak would be like, I can't really tell what's going on. Is it going up? Is it going down? They're kind of sketchy. It's just bad picture, right? Weak would be closer to very low strength, moderate, somewhere in the middle. I would say, yeah, this one's pretty moderate. Maybe a little bit, maybe, like I said, just because really this guy here, so maybe on the moderate strong, right? Direction. So direction is this. As I get bigger here, what's happening to the Y? Is it getting bigger, getting smaller, staying the same? Somewhat raising, right? Somewhat bigger. So then it would be positive direction. we're going in this direction. We're going in that direction, right? As I get people that weigh more, it would seem to be that their backpack weights is getting bigger, right? We said with moderate strength, we're pretty sure about that. Okay. Now there's better ways. We'll get more into these three things later in the chapter, but that's good. That's like a good way to start to kind of think about it. Strength is how much. So perfect 100% strength would be every dot lined up doing what they're supposed to. The opposite would be a cluster of just dots that are going, I don't know if they're going up. They're just kind of doing that, right? That's what that would be. Okay, something in between would be weak to moderate. Okay. Outliers, you will see outliers, but the nice thing about outliers now is there's no formula for these guys. It's just an eye test, the eye test. Is there one that doesn't fit the pattern? Is there one that doesn't fit the pattern? So for example, we said it's going this direction, right? An outlier would be someone who weighs a lot, but their backpack's very light, like down here. Someone who weighs more than most, but their backpack's nothing, right? Or the opposite, someone who weighs very, very little, but they have a huge backpack. Their backpack weighs a lot. That would be considered an outlier. Is this person an outlier? I would say no, because it's not that much less. Their backpack doesn't weigh that much less. I would expect them to be a little bit higher, but I wouldn't consider them an outlier. Do they stick out a little bit? Yeah, but they're not really. I wouldn't really consider them an outlier. Okay. So an outlier is an individual value that falls outside the overall pattern of what's going on. Doesn't do what it's supposed to. We said as X increases, Y is increasing too. Something that doesn't do that would be an outlier. Okay. And that's how you say I would consider it an outlier because it's doing counter to what it's supposed to be doing, right? As body weight gets bigger, their backpack weight is not where it's supposed to be. Or the opposite. For what they weigh, their backpack weighs too much. That's how I would explain they're an outlier. Okay? All right, so let's do a couple examples here. I don't give you a graph here, but just think about it. Let's say gas prices. This is a good one right now. Gas prices are coming down a little bit, but not as much as we'd hope they would. So gas prices. Let's say gas prices was my explanatory variable, and the number of visitors to that gas station is my Y. I don't have a picture, but what would you think would be going on? What kind of relationship or association would you think would be going on? What kind of picture would you expect to see if I were to do it?
More consumers at the gas station, higher the price.
So as X gets bigger, as X increases, what's going to happen to Y? So as gas prices go up, the number of visitors would also go up?
No, the other way around.
The other way around. Yeah, I think it would be the other way around, right? If you look at the gas stations that are always crowded, they're the ones that have lower gas prices. That's why they're always crowded. There's gas stations around here that you drive past on Shaw or Herndon or whatever. Their gas prices are just crazy high. They never have anyone there, right? So yeah, I would say as gas prices increases, let me draw this picture. So we would say this is gas prices. We would say this is visitors. I would expect to see something like this. Right? I would expect to see something like that. As gas prices increase, right? What's that? No. Okay. As this guy gets bigger, less people are going to come, right? So that would be a negative association. A negative association. What type of strength would that be? Strength. What type of strength would that be? Let me ask you, those of you that drive, if gas prices are crazy high, will you be going to that gas station? Heck no, right? So if you're pretty confident in that answer, it's going to be pretty strong, right? It's going to be pretty strong. You don't see a lot. You will drive around as you're driving around. Look at the gas station prices. Look at the ones that are the highest. There's some that are like $5.50 a gallon. There's nobody there. There is nobody there. Guaranteed there will be nobody there, right? The ones that have gas prices of like $4.50, those are going to be crowded. Right? Those are going to be crazy. You're going to have to wait, right? That would be pretty strong. Okay? All right, so let's do the next one. So let's say this is X and this is Y. So number of umbrella sales and number of car accidents. So if I counted how many umbrellas were sold in Fresno for a day, and I did that for a month, and then the same day, I counted how many car accidents we had in Fresno. Well, that's what I'm asking. How do they go? So we have three options. They're positive. So as one's going up, the other is going up. So dots like this. As one goes up, the other goes down. So as more people buy umbrellas, there's less car accidents. Or there's no relationship. There is no relationship. They have nothing to do with each other. So what would the strength be? Weak, if anything. I would say they really have nothing to do. What do the number of umbrellas sold have to do with the number of car accidents? Nothing. There's really nothing there, right? So it's not going positive, it's not going negative, it's going zero. Right? Well, that's what someone said, actually. That's what someone said before. They're like, well, Mr. Flores, how about this? When do people buy umbrellas? During the rainy season, right? And what also happens on the streets during the rainy season? So they got a little deeper, and they said, as the number of umbrella sales goes up because it's raining, so will the car accidents. I'm like, that's a good observation. That could be right. Right? So yeah, there could be a relationship there, positive relationship, maybe a moderate, But me personally, I don't see any relationship between the two. Yeah. I mean, you look on the internet, watch, I'll show you some. There's some crazy ones that have positive relationship. Watch, let me see.
Basically, it's just like if the question were to say in Seattle, what do you think? Or if it was in Fresno.
What's that? Say what?
So basically, the question said if it's in Seattle at the end of it, is the stereotype for Seattle that it's usually raining, then we would probably choose positive, moderate ones.
Yeah, it just depends. You can make a case for both. That's what I'm saying. You can make a case by both. That one's a little dark.
Oh.
Here we go. The number of people who have drowned by falling into a pool versus the number of movies that Nicolas Cage has appeared in. Are they have anything relationship? Well, if I looked just here, right? Let's see. Here's one. The number of cheese per consumption. How much people eat in cheese versus the number of people who have died by becoming tangled in their bed sheets. What's that? I'll post a link. I could post a link. Right? They both seem to be positive. What the heck's going on? So here's the thing. This is why I'm showing it to you. Does it mean that the more cheese people eat is causing people to become strangled in their bed sheets? No, it's not causing. There's not. It's not causation. It's called correlation. It means there's a relationship there, but it's not causing one, right? That's why they put this website on there, because that one shows positive for both. They're both going up. The correlations is very strong. But we're not saying one causes the other. I'm not saying if I go to Save Mart and buy as much cheese as possible, people are going to die tonight. That's not what it's saying. It's saying that there's a relationship there. Okay? Divorce rate in Maine versus the per capita consumption of margarine. Margarine's the fake butter. So it's saying as people are getting less and less, or as less people are getting divorced, people are buying more margarine. Or no, wait, which one is this? This one is, they're both decreasing. Does that mean they have anything to do with each other? No. But there is a correlation. There is a relationship. By steam, hot vapors, and hot objects. Well, that one's kind of crazy. That one's all over the place. So that one, there's really no relationship there. Here we go. Total revenue generated by arcades versus computer science, people who get their PhD in computer science. That's right. That's pretty high. So this is what you're looking at. This is what you're looking at. You're looking at the association or the relationship or the correlation. We'll get to correlation here in a little bit. Does that mean one causes the other? No, we're not talking about causation. If you want to know what causes what, that's in chapter 4. I'll tell you what. I'll tell you that's causation's in chapter 4. Right now, we're just trying to see if one thing has anything to do with do with the other thing. Okay, that's all we're saying right now. All right, correlation. Correlation is kind of like association. They're very similar. Okay, correlation. Correlation. Correlation goes by the letter R. Why did they choose R? I have no idea. Why didn't they choose C? I have no idea. Or actually, I do know, because C means something else. It's like slope. What letter did they use for slope? M. Why did they use M for slope? I have no clue. I have no clue. Why don't they use S? Well, they don't use S for anything because it looks like a 5. It can look like a 5. So S, mathematicians don't use. So why did they use R for correlation? I have no clue. But anytime you see the letter R, it means correlation. Okay, maybe because it's got 2 R's in it. That's why they put I don't know why. Okay, but what is correlation? Correlation is almost identical to association. They're very similar. The difference with correlation is it's a number. It'll actually give you a number. Okay, so correlation measures the strength of the linear relationship between two bivariate data. So R is always between -1 and +1. It's never bigger than 1. It's never less than -1. R positive means a positive association. Positive association, direction. Okay. R less than 0 means a negative association, direction negative. Okay. Values close to 0. If R is close to 0, that means very weak to none, no direction. Okay. The strength of the linear relationship increases as R moves away from 0. So as R gets bigger, it becomes stronger. It moves from weak to moderate to strong. As correlation gets closer to -1, it goes from weak to moderate to strong. I'll show you a number line in a second. The extreme values, R equals -1 and R equals 1, occur only in the case of a perfect linear relationship. They line up perfectly. Okay, so here's some examples of R. There's 5 examples. The first one, R is close to -9.5. This is very strong. This relationship right here, I would consider very strong. Is it a positive or negative relationship? Negative relationship. So it would be a strong negative linear relationship. The dots are almost lined up perfectly. This one is still negative, right? I can tell that as x increases, y is going down. So it's still negative, but I would say it's closer to a moderate. Okay. 0. Can you tell what's going on here? As x is getting bigger, what's happening to y? Can't tell. Can't tell. So it's not even weak. There is no relationship. There is no correlation. They have nothing to do with each other. 0.6 is the same as negative 0.6, but it's going up instead of going down. Same thing with 0.95. Okay. So let me give you a number line. So let's do a number line real quick. Okay. -1 is the lowest you can have. +1 is the highest you can have. -1 and +1 are what we call extremes. They are perfect negative, perfect positive linear relationships. They're a straight line, either going positive or going negative. Okay. So we would consider it weak up until about 0.5. 0.5. So let me put 0.5 here. 0.5 would be right here, and -0.5. So if it's in here, I would consider it weak. If R is anywhere in there, I would consider it weak. Okay. From 0.5 to 0.8, so a little bit more, and -0.8. I would consider it moderate. Moderate. And then the last one on the edges here, I would consider it strong. Strong. Okay. So here to here, weak. Here to here, moderate. And the edges here, very strong. Very strong. Okay, because you're going to calculate R, and they're going to ask you, what does that number tell you? So you have to say 3 things. What's the strength? Look at the number line. Is it weak, moderate, strong? What's the form? Always linear. What's the direction? Well, if it has a positive, if it's over here, it's going to have a positive relationship. If it's over here, it's going to have a negative relationship. If it's at 0, it has no relationship. Okay. All right. So let's look at this guy here. Let's look at the, let's see. We'll do these last couple and then we'll be done for today. All right, so let's look at this example here. This one's height and weight. Height and weight. X is height, Y is weight. Weight of what? Height of what? I have no clue. People, I'm guessing. I have no idea what that was. They didn't tell me. Okay. So which one does it best? So we don't have a number, but what would be the strength here? Would you say that these green dots are pretty weak, pretty moderate, or pretty strong association? So here's how you tell. Do I know as height gets bigger, do I know what's happening to weight? Going up, right? If your answer pretty quickly is yes, then it's probably going to be either moderate or strong, right? If you're kind of like, I think, that's weak. Okay. So yeah, so you guys answered pretty quickly. As height goes bigger, so does weight, right? They're kind of their dots are moving trending in the upward position. So I would say probably moderate, right? Probably moderate. There is a moderate Positive or negative, because they're moving up, right? Linear relationship. Always those two last words. Linear relationship or association. Actually, I probably should put association because they ask. But how much of a straight line do all those dots make? Not a very good straight line. I would expect something more like this. That's pretty strong. These dots, they're all kind of doing the same thing. So that's why I said there's a positive relationship, but I would say more moderate than anything. I would expect an R probably somewhere in this range right here, right? Probably closer to 0.5 than to 0.8, but somewhere in here, if I were to actually calculate it, which we're going to do tomorrow, I will, yeah. Okay. All right. So two things. I want you to do the next example, A and B. Do A and B. Last thing we'll do. Actually, no, we'll do something on the calculator too. This is the last thing you got to do in your notes. Okay. So tell me what kind of relationship, what kind of association, what kind of correlation. They all very much go together. This one they actually tell you. Hold on. Yeah, just put it right there on top. Perfect. Yeah. Okay, so let's do A first. As years is getting bigger, right? Years since 1900, 80, 85, 90, 95, 100. As years gets bigger, what are the dots doing? Are they climbing or rising? Climbing or rising. Are they climbing or falling? Falling, right? So there's a negative. So we would say a negative. That's one word. Now, how much are they falling? Are they all kind of doing the same thing? Is everybody kind of on the same page? Or is it this? Remember, this was a moderate here. Which picture does this most represent on here? Is it closer to a 0.6 moderate, or this one? Or is it closer to a 0.9 negative 9.5? Personally, I think it's closer to this. This one is kind of, I get the general idea, but it's not as strong, right? That's kind of like this one. This one, I mean, if I drew a line there, that's pretty close to all the points. Maybe not this one, but you know. So I would say at the very least, moderate to strong. Moderate to strong, but I would definitely include the word strong in there somewhere. Linear relationship. Okay. How about this guy here? Is it positive or negative? Another negative. This one kind of looks the same, right? Maybe a little bit off. Like they don't all kind of, you know, maybe there's a couple more points here. So maybe this one moderate to strong, but I would definitely want to include some kind of strength strong in there. So maybe I could say moderate to strong linear relationship. Okay. Okay, last thing I want to do. This won't take that long. Calculators. Get your calculators out, go to your list. Go to the list.
God bless you.
Go to your list. We're going to put a list. We're going to put two lists in there. We're going to create a scatter plot. That's what we're going to do right now. We're going to create a scatter plot. So you're going to put those two lists in there. L1 is going to be X. L2 is going to be Y. L1 is going to be X. L2 is going to be Y. Put your X list first, put your Y list second. So we'll take up two lists. You can erase any list that you have already in there because that's from last chapter or 2 chapters ago. Okay, so backpack weight, or sorry, body weight. X goes first, Y goes second, just like in the alphabet. Okay, that's list 1, and then backpack weight. So you want to put them together, though. Person who weighed 120, their backpack weighed 26. So I got to put them together. So make sure they go together like that. Okay. So now what we're going to do is we're going to make a scatter plot. Okay. So we're going to go to where we graph. Graph is stat plot. Stat plot. Okay. So go to stat plot, and then you got there. Okay. Graphs are plot 1. Make sure it's on. We've used almost all of them. Actually, we've used the middle 3, right? So the one we're going to use today is the first one. That guy right there. The dots. That's the scatter plot. We got to tell it, where's my X list? Where's my explanatory? That's in list 1. Where's your response? Mine is in list 2. So I'm going to go hit second 2 because that's what list 2. Okay. Now I need to go graph it. Zoom stat. And there you go. Picture's very close to the one we made. Very close to the one we made. Okay. Tomorrow I'm going to show you. So from now on, you can use your calculator to graph these guys, and I'll show you how to write it. You don't have, I'll show you tomorrow because I don't want to get too much into it because we're running low on time. But your calculator will do scatter plots. It gives you the same picture by hand as it does by, on the graph. Okay. All right. Okay. So we'll pick up tomorrow. I'm not going to assign anything today. So tomorrow I'll assign something tomorrow because we'll finish up with correlations.